Good morning. So today let's talk about what shape the universe is, like the topology of the universe is in my model, and why. Okay, so in previous video, I described how I see the local model. This is going to be like a one-dimensional thing, looking sort of two-dimensional of three dimensions, right? And these are drawn as balls. I don't think the universe necessarily has to be balls. It could be fluidic, like more like, and this is just all spinning, right? It's all spinning. This would be the axis of spin. This is the spin. To us, it's going counterclockwise to antimatter universe. Our universe is the symbol I like to use for it, just to sum it up. There we go. I don't know if there's another one. Antimatter, matter. Now, this is the vacuum energy, which is basically photons going like this. Right. It would be a lower frequency photon underneath them. I guess it could stretch out to any length, going sideways, making it all spin, not in any way apparent to us, because what we see is still this. Let's do it that way. Continuous fluid surface. And this might be an electron, in which case it would be three directions. These would be three axes in three dimensions. See my particles: one, outflow, outflow, pure outflow, positron, pure inflow. But that's not our side of the universe. Our side of the universe, the inflow into our space is the electron, and the outflow is the proton, because it's got a little mass unit attached to it, because in our future, the future is more dense. Eventually the electron gets squeezed back into the proton and you get a neutron out this way. But that's two black holes. Photons would be go like this. This would be one side of the photon. This is a phase. Yeah, this is an out of phase, disproportionately phased somehow photon. I'm not even sure if this is possible. Okay, so here is the inflow side on this. That was the inflow. So that's a positive front. This was the negative one. That's the outflow. Inflow. Just an outflow. And it goes right like that. So we have a photon. One of our photons would travel like that. These photons are traveling like that. They're sinusoidally in plane to us, and therefore you don't see them or notice them because there's no chargy part. And that's the thing right now. We can't see the fluid flow. That's a Haranov-Bohm aspect. You can only see it when it's attached to a charged component. So, yes, inflows, outflows. So we have this layer, but this whole thing is really supposed to be the skin, in a way, of infinitesimal time. Right? Like this is just a skin. But where's the larger aspect of it? I haven't introduced gravity into this yet. Okay, so let's blank our slate. And the object, because that's how I roll. Okay, so here we go. Okay, it's moving a little more upside and wonky, but there we go. Okay, so this is our space, let's say, right? And this is the way gravity goes. This is future time. This is this direction, getting denser. Let's see if there was marks, it would be it. These are like density marks. Energy density. So this would be black hole event horizon kind of situation. Right? Event horizon, I believe black holes exist, really, in a way. It's in my other notes. Okay, so this goes the other way, and this is getting less dense. Okay, so this is our rotating thing, and this is like an outflow, and this is, so this is our universe, let's say, and this is the antimatter universe. Okay, and here is infinitesimal time that everybody wants to get to, because it's got everything. Space is isotropic, and therefore it actually moves towards density. Because density is smaller, so it has to flow to fill in the gap. Okay, so there we go. This is our direction. Let's say it's sort of our up. At this point, though, what I think happens is it goes like this. Okay, I think that's right. No, where does it join onto? There, that's not right. Damn. Okay, well. I drew it, but I muffed it up, so I'm going to draw it again. Let's draw infinitesimal time there. Okay. So this is the cone of the plane of the universe. This is getting denser. This point there is, you know, event horizon density. Okay. Okay. So this is the gravity future time direction to this point. At which point you become the vacuum flux, infinitesimal time itself sort of thing. And then you re-emerge here as a neutron. You go in as a neutron, you come out as a neutron. But you actually, if you look, it's like, wait, this is the antimatter universe. Folded into the antimatter universe. So this is the antimatter universe side. This is the whole membrane. This is time. This is time. Like a Marangoni current, so to speak, between two membranes. But the Marangoni current is spin itself. This whole thickness is the vacuum flux, thickness of one infinitesimal time. You pop in, you actually come out inverted. But because everything that's on that side is also mimicked on this side, it's sort of like you didn't get inverted. But the geometry sort of says that you get inverted. Notice, you're pointing up. Now you're pointing up, but you're pointing up in the antimatter universe because you flew over this. Okay. And again, this is why baryon is symmetry. This is spinning to us, let's say. To us, looking down, that is spinning counterclockwise, down into counterclockwise. But from that side, what you see is it's spinning. The same thing. You see it as the same. If you're in the antimatter universe, there's nothing different to you. You see our side is seeing it backwards, and we see their side is seeing it backwards. From our side, they are seeing it going clockwise and up. There's a chirality or world lines. Where was I? There we go. Time forward. Direction. Gravity. You get inverted. Now your poles are this way, but because everything's mimicked, it's the same thing, so it's actually a neutron that manifests here too, and only an anti-neutron manifests there. It could be as particle clusters, because if it's less energy, I guess, to make a neutron anti-neutron pair, then we should see those decays. And maybe we see a very range, but the nature of the neutron-neutron thing, I think, is like basically inviolate and just like too perfect. Neutronium falls in, neutronium reemerges, but this is neutronium ensemble, and this is neutronium spread across as distant parts of the universe as possible, where it tangentializes, as I like to say, and goes from a point to a volume. This is the thermonuclear, this is this thermoentropic poof. This, now it expands, now it contracts, now it expands, now it contracts, now it expands, now it contracts. And this all because of the nature of space itself, that it gets more dense when you apply energy, and it also becomes less viscous. This is a fluid model of the universe. This is the topology. So memes there. Okay, I think that's it.